Okay. So the last time, as we know that we have studied about constructors, I hope you all have revised it properly. Now, the next topic after constructor happens to be static. Okay. Now, static, as you know, is a keyword. Okay. When you write the main method, you write public static void main string args. Correct. So there is a word called as static. Now, if you remember, while I was explaining the main method, I told you public is used to make the main method visible, whereas static is used to make it accessible. Now, what is the use of static? Exactly, word to word, you will understand. Also, understand that the word static is used for accessibility. Okay. Now, what kind of accessibility? Now, understand, if a variable, a block, or a method is static, it is directly accessible without object creation. That is the benefit of a static keyword. Okay, all this, what's gonna happen, how it's gonna happen, we're gonna see everything step by step. Okay, so let's start the topic static. Let me quickly share my screen. So what you're gonna understand today is the keyword static. Okay, so it's also present in the main method, as I have already told you. The use there is kind of similar what I'm going to explain here, but static does not just doesn't mean a static method. Okay, we have static variables, we have static block, we have static methods. I'm going to show you one by one each one of them. Okay, now let us see a thing called as accessibility chart. Okay, even before that, let us see what are the static elements that are present in our program. Now, understand, all these days you are not aware about it, okay, but there are 3 static elements that are present in our program, or in other words, that you can add to a program. The choice is yours. If you want, you can add them. If you want, you need not add them. Okay, so static variables are the very first static elements. Second is the static blocks. Third are the static methods. These are the 3 different type of static elements that can be present in our programs. Now, what are other elements that can be present in our program? Other elements that can be present in our program are non-static variables, non-static blocks, and non-static methods. Okay. Now, these are the 6 different elements that can be present inside a program. All this time that you have coded and moving ahead, whatever you will be coding will be a mixture of all these 6 elements. Might be some of them will be missing from the program, might be all will be there. The combination is different depending upon your requirement. But yes, whenever you write a program, it consists of only these 6 elements, nothing else. Okay. Now, understand, if you remember, I told you, right, that all these days I was telling you the main method is where the execution starts. Main method is where the execution starts. Yes, I had to tell you like that, because all these days I was not able to explain to you where the actual execution begins. Okay, I always told you, right, that the OS gives control to the main method. It kind of does, but not exactly. Okay, because you're not aware about so many things. Okay, hence I was not able to tell you, but today you're in a position to understand what I'm going to explain. Okay, so understand, let me tell you, never tell to the interviewer that the execution begins with the main method. It never does that. Remember, in any program, in any Java program you take, the very first thing that gets executed is the static variables. Then it is the static block. Then is the static method. Then it's the non-static variables, non-static block, and the non-static methods. This is the execution flow. Okay, and a main method is a static method. Don't you think? You only tell it, right? Public static void main. So even the main method is a static method. Because see, now don't think that all these days I have been teaching you wrong. No, I have been teaching you the correct thing. Because all these days you have never written or created a static variable, neither you have created a static block. So where did the execution start from in your programs? Static methods. So remember, yes, all these days, because you did not write static block and static variables, your program used to start execution from static method. That is the main method. But that doesn't mean in all the programs and every time the execution will begin with main method. No. Okay. The execution in any program starts with static variables and ends with static methods. Maybe if static variables are not there, then it will start in static block. If static block is not there, then it will start from static method. That's a different scenario. But always the execution begins with static variables. Okay, I hope this makes sense now. Next. Now understand, because the elements execute or understand, because the elements here execute in a flow. Okay, this first, then this, then third, then fourth. Understand, there's an accessibility issue there. Okay, not every block or method can access every variable. So let us see what happens. Remember, a static block can access a static variable. Similarly, a static method can access a static variable, because till the time static block executes, already static variables are created and executed. Till the time static methods execute, static variables are already executed. So they are accessible. They are already inside the memory. It is present. Similarly, a non-static block can also access a non-static variable, because it is already executed before it. Even a non-static method can access a non-static variable. But not just that, even a non-static block can access a static variable, because it is way beyond already created. Similarly, a non-static method can also access a static variables. This all is allowed. This all are legal accessibility. But if you try to access a non-static variable using a static method, it is not possible. Why? Because this has yet not executed. If it is not executed, means it has not been allocated memory on the RAM. If it has not allocated memory, then it is not existing yet. It is not there. And how can you access something which is not there? Correct? So this is not allowed. Similarly, a static block cannot access a non-static variable. Okay, so this is the accessibility chart, and this on your right hand side is illegal accessibility. Okay, if you have understood this, very good. If not, then also okay, I'll give you a simple way to remember it. Let us assume you all are in colleges, right? So let's assume this is first semester student, this is a second semester student, third, fourth, fifth, sixth. Okay, there are 6 students of 6 different semesters from 1 to 6, let us assume. Okay, now you only think, can a student who has cleared the first semester and reached second semester, okay, now can a second semester student know the subjects of first semester student? Yes, he knows, because he has passed first semester and came to second. Similarly, can a third semester student know what is the first semester subjects? Definitely. Similarly, a fifth and sixth semester students can know what is there in the fourth or the first semester. Remember it in this way. But understand, a second semester student will not know what is the subjects of fourth semester student, or a third semester student will never understand what is the fourth semester subject. Okay, that is illegal. You can remember it in this manner also. Okay, so this is the accessibility chart. Any doubts in this one?
No, sir.
Great. Not only that, let me show you how each of these elements look inside a program. Okay. See, this is a program where I have mentioned all the 6 elements. I have been using all the 6 elements in this particular program. If you see the very first line, I'm creating static variables. Okay. And I have written one as in this will be executed first. Okay. So static integer type ABC. So ABC are the 3 different static variables we have. Then we have non-static variables, which are executed at the 4th. Okay. So we have X, Y, Z. So non-static variables, as you can see it, they're nothing but the instance variables. All these days, whatever instance variables you have created, you have been creating the non-static variables. Then we have a static block. Now, you have never seen anyone writing a block. Okay. A block is nothing but any number of statements written inside a bracket. Okay, can you see this is the starting of the bracket and this is the ending of the bracket. Whatever you write between this, okay, the complete thing makes it as a block. But because it's a static block, we write static at the top. Okay, so this is a static block. It executes at 2nd position. Then there's a static method. We all have seen static methods. We have seen a main method. This is another way of writing a static method. So I've written static void display one. Okay, then there's a non-static block. See, I told you the difference between static block and non-static block is static keyword is written but for non-static block nothing is written at the top. This is a non-static block. Okay, you can write any number of statements between it, but it will execute at the 5th location. It's the 5th element which will execute. Then there is a non-static method. Okay, void display 2. Okay, so that it executes at the 6th position. So this is how, if you write or add all the 6 elements in the program, this is how it will look like. Okay, now a small note. First thing, a static block and static members can access static variables. We have already understood it, okay, via this diagram. Then we have non-static blocks and non-static methods can access static variables. Yes, we know. Non-static blocks and non-static methods can access non-static variables, that is nothing but the instance variables. However, static block and static methods cannot access non-static variables. We already know why, because till the time this 2 is getting executed, this has never got executed. Hence, if it is not executed, it is not created, there's nothing to access. The first step in a Java program execution is by allocating memory for static variables. So because the very first thing in any Java program execution, while the Java program is getting executed, the very first thing that happens is always the allocation of memory for static variables. Hence we say it is the very first thing that gets executed in a program. Okay. Yes, and what is a block? Any number of statements inside a bracket is called a block. For static block, static keyword is mentioned. Okay, so whatever I have taught in this slide, I have already written it as a note so that you need not go through while you're revising. You need not go and see this diagrams and remember, okay, what he told. I've already written most of it in a note so that you can see it, read it, and you can remember it. Okay, if you have any doubt, please do ask. If not, please quickly take a screenshot of this one.
Yes, sir.
Okay. Now, the next thing I wanted to show you all is the program actually. Okay, I'll maybe show you here first. Okay, so this is a program that I have written. In this program, if you see, it's kind of a same program, but few additional things I have written. Okay, this static variables, as you can see, there is instance variables, or you can call it as non-static variables. Then I have written a constructor here. Okay, which is initializing the non-static variables XYZ 200, 200, and 300. Then we have a static block, which is actually initializing the static variables. Okay. Then we have a static method. Then we have a non-static block. Then we have a non-static method. Okay. And finally, we have this. We have a main method where we are trying to display some things here. Okay. We're trying to call display one, and then we're trying to create an object and call display two, and then we're printing, calling static method using reference. So I'm going to explain you everything. Just wanted to show you the program first. Okay. And if I save and execute, so this is the output that I'm getting. Okay. Now, why am I getting this output? How to achieve it? What is happening at the background? I'm explaining you in a moment. But remember, when I explain this, I'm not going to show you the control flow for everything, because in the past 2 days, I have been showing you, or the past 2 sessions, I have been showing you how to create the control flow, where the control comes from and where it goes. So I hope now when I tell the control from this particular location is coming to this location, you can keep it in your mind and imagine it as well. Okay. So if I execute this particular program, okay, which I just showed you, this one. Okay. If I execute this program, what happens at the background? What happens in the memory? How things execute? Exactly, I'm going to show you. You have never seen when all the 6 elements are present in a program, how the program actually behaves. You have never seen that. So let me show you this time. And I want all of your concentration in this program for this particular moment, because it's actually very important. Okay. Now, let us assume this is the code segment. The code segment will definitely contain the code. Okay. Now we have a stack segment, we have the heap segment, and we have the static segment. Okay. These are the 4 different segments or 4 different parts of JVM, if you remember. Okay. Now, once the code is loaded in the code segment, the second thing that happens in Java is JVM actually gets loaded into this. Sorry, I'm really sorry. I told you that this for a part of JVM, this for a part of JRE. Okay, Java's runtime environment. I'm really sorry. So my bad. All the 4 parts that you see, code segment, stack segment, heap segment, and static segment, are part of JRE. Okay. The very first thing happens is the code is loaded onto the code segment. Second thing that happens is on the stack segment, JVM gets loaded. JVM as a software gets loaded onto the stack segment. Now what happens? Okay. Now watch carefully. Let's assume this is the OS. OS gives the control to JVM. Okay, that's what actually happens. It is always the operating system giving control to JVM, which is present on the stack. Now what? JVM doesn't keep the control with him. He passes the control to another software. He passes the control to class loader. Now, what is class loader? Class loader is again a software which is having a particular job. What job does it do? If you ask me, the job of class loader is to scan the complete code segment. Okay, its job is to scan the complete code segment and analyze how many static elements are there. Now you only see in this program how many static elements we have. We have static variables, we have a static block, we have a static method. Not only one, we have 2 static methods. If you notice, we have void display one and we have main method. They both are static methods. So all the static elements, it will scan the class loader and it will pull them into the static segment. Notice that is the job of class loader. It loads all the static elements onto the static segment. Now, once done, the class loader job is over. It gives back the control to JVM. Okay. Now, JVM's job starts. JVM starts to execute everything that is present onto the static segment. That is the only job of JVM as of now. It will execute everything present on the static segment. Now, Remember the program execution flow? I told you the very first thing that executes is what? It's a static variable. Can you see the very first thing is the static variable? Yes. Now executing them means allocating their memory. Now because remember it's a static variable, it allocates memory in the static segment only. It doesn't create memory here or here. It creates memory in the static segment. Okay, so let us see when the very first line executes, when JVM executes this first, what happens? This happens. Three variables are created, A, B, C, and they are given a memory and a default value by JVM. Second, remember after static variables, static block is executed. Can you see the static block here? What is it doing? It is initializing the variables A, B, C, that is the static variables, to a initial value. So with this, we also can understand that one of the usage of static block is to initialize the static variables. Okay. So let us initialize them. See, A got 10, B got 20, C got 30. Now what? Now, and the third, static method should execute. Now there is a confusion. All this time we had only one static block and a set of variables. But now we have static method. How many? Two static methods we have. Which one should be executed first? This is a question I'm asking to all the members in this team. Okay, which method or which static method should execute first? What do you think?
Display method.
Okay, Jyoti says display one method should execute first. What about others? Others are also there in the meeting, right?
Display one method, sir.
Okay, Simran also tells display one method. What about others? Srisha, what do you think? No thought at all?
I think main method, sir.
Okay. Okay. Okay, let's see. Understand. few of you are telling display one, few of you are telling main method. Let's assume that. Understand. Yes, first static variables executes, second static block execute. But remember, when it comes to static method, even if there are 1,000 static methods, the very first static method which will execute is the main method. Don't you think the name itself tells you main method? It is main, it is important. First execute me. The name itself is telling I'm the main method, I'm important, execute me first. And remember, it always executes the main method first. Even there are 1,000 methods, 1,000 static methods available. You'll leave all 1,000 and it will execute the main method first. Okay. So understand that among them two, the main method is gonna get executed. But again, at the end of the day, it's a method. So whenever JVM executes or the control enters a method, what happens? An activation record is created on the stack segment, correct? So as you can see, the next thing that happens is an activation record, or you can say stack of main is created on the stack segment, correct? Now, because it is loaded here, the complete code would be here, but I'm not showing it. I hope you all remember it. So the main method will start getting to execute. Now, if you see the main method, what is the very first line of the main method? You're calling another method display one, but you're not creating an object for it. Why? Because the display one method is none other than a static method. Remember, they are somewhat VIP methods. Okay, they do not need object creation and all. Static methods can be called directly through the class name. Okay, That is the benefit, that is the profit of static methods. Okay, so remember, whenever you create or declare a method as a static method, we need not create object to call it anymore. We can directly call it through the class name. See, because display1 is a static method and it is present in a demo class, I can directly call it in another class by telling demo.display1. I need not create an object to call it. But if it is a non-static method, I have to definitely create an object and call it. I cannot call it through the class name. Okay, so static keyword gives us accessibility. Okay, we can access that method from any place just via the class name. So because this is the very first line, obviously you all know that the control from here will enter this particular method. That's a static method, but at the end of the day, it's a method. So one stack will be created for display1. Now all the lines in display1 will be executed. So ABC will be printed on the screen. Now tell me, what is the value of ABC? 10, 20, 30, correct? So if you notice the output here, the very first three values were 10, 20, and 30. Okay, that's how we got the first three output. Now what? Once the execution is over, the control from here will come back to the same line. Okay, now once it comes here, we also should understand that this is removed. Okay, so I cannot remove it, so I'll just draw over it. Okay, like this, that this is removed. Okay, remember it in this way. Now who is at the top of the stack again? Main method. So we'll start executing main method again. So we already executed this line. We'll come to the next line. Next line is object creation. So you know, equals to sign, so right hand side will be executed first. New will give us a new block of memory on the heap. Let's assume the address is 3000 for that. Next is demo. So we'll go to the demo class and see how many non-static variables are there, or in other words, how many instance variables are available. They will be created inside this object. See X, Y, Z, and also JVM will give them the initial value, that is 0. Now what? Finally, we are calling a constructor. Okay, I hope you understand. This is a constructor call. So from here, this particular constructor will be called because I have written a default constructor or zero parameterized constructor. Now, in this construct, once the control comes here, it will start executing this constructor. The very first line. What will be the very first line? This is the question. It's an open-ended question for all of you. What will be the very first line? What?
X is equal to 100.
That will be the very first line. Anyone else?
No, sir, it will print again the static variables ABC.
Simran, understand the question. I'm asking from here, the control, we called a constructor, right? In this bracket, we are calling a constructor. So the control from here reached here. Now this is a constructor. If you see, it's having the same name as that of the class. It is having no return type. It's a constructor. So from here, the constructor will start getting executed. What is the very first line of a constructor? That is my question.
Okay. X is equal to 100.
That is okay. You're telling X equals to 100. Anyone else? Jyoti, what do you think? What is the first line of the constructor?
It will initialize 100.
Okay. Trisha, what do you think?
No idea, sir.
Okay, that's also a correct answer. No idea. Okay, fine. Again, this shows heavy lack of revision, or else I have not been able to explain you properly. But I don't know what's the mistake here. I hope you remember the very first line of a constructor is super method call. That's what we have studied the last day. Okay, If I do not write anything, automatically the very first line of a constructor becomes super method. If I would have written this method, then super method would not be the first line of the constructor. Then this method will become the first line of the constructor. But if I'm not writing anything, neither super, neither this, automatically super becomes the first line of a constructor. This shows really lack of revision, or else it's my problem. I am not able to explain you. I don't know what's the problem here. Anyways, that's really not good. Anyways, moving on. So super method is as we all know it, I hope you all remember. If you do, it will take the control to a parent class constructor. Parent is, there's no parent for demo, so automatically it will extends object. Okay, so it will go to the object class constructor. Once it executes that, it will come back to super. But understand, after that, I told you that this 3 lines will execute. That's what I have explained to you all these days. But understand, I explained you that because all these days we did not have a non-static block. Remember, every time a super method executes, after that, the control always tries to find a non-static block. So from the super, it goes to a non-static block, always. You create 1,000 objects. For each object, whenever a super method is executed, after that a non-static block will get executed. That means after super, definitely a non-static block is getting executed. So if you see, that's why we are getting this as the solution here, the 4th line inside non-static block. Okay, after that, once the execution is done, nothing is left here, I can give the control back to the same line, that is super. After that, whatever is there in the constructor will get executed, that is x equals to 100, y equals to 200, z equals to 300. So you can see the values changing here. So all they are initialized to a new value. After that, there is nothing left in the constructor to execute, so the control will come back to the same line. That is, the RHS is completely executed. So in LHS, okay, demo type D will be created. So as you can see, it will be created inside the main method. In other words, the stack of main method. Okay, and it will point towards this object. After this, the next line will be getting executed, d.display2. Because display2 is non-static method, I'm calling it via the handle or the reference. Okay, so I'm calling d.display2. So again, it's a method. So the control from here will come and enter this method. And whenever a control is entering a method, I hope you remember that a stack is created. So again, as of now, display2 is at the top of the stack. So again, display2 will start to execute. So display2 is telling to print A, B, C, X, Y, Z. So again, ABC, as of now, what values it has? 10, 20, 30. So it will print 10, 20, 30, and XYZ has 100, 200, 300. That's what it will be printing. So if I go back, if you notice, that's what it is printing: 10, 20, 30, 100, 200, 300. Okay. Now what? Now after that, there's nothing left to execute. The control will come back to the same line. Again, the control left this particular method. So definitely, this is no more at the top. This will be removed. Once it is removed, again, main method becomes the main method comes at the top of the stack. So again, we'll start executing main method. The next line is system.out.println. So it will just change the line. You can see, okay, here I have written something else, hence the output is different. I'll just remove this 1 second. Let us have a blank print only. Okay, so as you can see, it is changing line. There's nothing getting printed here. Okay, because there's a println to change the line. Now again, I'm calling display1 method. It's a static method. Now why am I calling this? Just to showcase that the display1 method is a static method. We can call it directly without creating an object using the demo. That is a class name. That is a class name here. Or else, if you want, you can also create an object of the class and call it via the object reference. Okay, both is allowed. Either you call it through the object or call it through the class name, but we always prefer calling it through the class name. Why should we create an object for that when it is already accessible without a object creation? But can we call it? Yes, that is what I'm trying to show here. So again, d.display1 will be executed. That means this stack will be created here. So again, the control from here will enter this method, execute abc. We are going to get the output 10, 20, 30 here. And finally, when the control comes out, it will enter this. So again, this one will be deleted. So this will be no more at the top of the stack. Again, it is the main method who is at the top of the stack. And with that, we will again start to execute the main method. And again, there is nothing left in the main method to execute. Even this will be destroyed. Even the object will be destroyed, and the stack will be cleared. And the output we are going to get is this one. So I hope you have now understood how we are getting this output. Okay. So remember always, first the static variables execute, then a static block executes, then the static method. In static method, the main method executes first. Okay. Second thing, non-static variable gets executed whenever you create an object. Whenever you create an object, okay, whenever the constructor call is made, whenever a super method is executed, instantly after the super method, a non-static block gets executed. So remember, for every object created, the non-static variables and the non-static block is definitely going to get executed for every object creation. Okay. And if you call the non-static method, you can call it and it will be executed. But here what I wanted to show you exactly is, understand, if you notice, we are trying to access a we are trying to access abc from this non-static method. In other words, what I tried to show you here is we can access static variables using a non-static method. Okay, this is what I wanted to show you. So this is also what I wanted to showcase, that even a non-static method can access a static variable because they're already created. But remember, if you try to access a non-static variable using a static method, it would not have worked. Okay, definitely it would have not worked. That is what I'm going to show you in the next program. Please quickly take a screenshot of this. If you have any doubt, you can ask me.
Yes, sir.
Okay. Also, take a screenshot of the output. 1 second. Let me just clear the screen first. Yep. Take a screenshot of the output also.
Yes, sir.
Okay. So once this is done, let me show you. Okay, if we try to execute, okay, the same program, but if we are in this program, we try to do this. Here you can see I'm trying to access non-static variables using a static block, and I'm also trying to access a non-static variables using a static method. In such a case, what happens? As we all know, the complete program will come and sit in the code segment. Okay, now the very first thing that is happening is JVM is going to get loaded onto the static segment. OS is going to give a control to the JVM. JVM will give a control to the class loader. Class loader's job is to scan the complete code segment and put every static element onto the static segment. So that's what it's going to do. Now, once it is done, it's going to give back the control to JVM. JVM job is to execute everything on the static segment. It will start with the static variables. So it's going to give the static variables its memory on the static segment. So A equals to 0, B equals to 0, C equals to 0. Okay. After that, it will start executing the static block. In the static block, if you notice, the very first line tells to initialize A, B, and C. So it will initialize A, B, and C. But as soon as it tries to execute this particular line where you're initializing X, Y, Z, what will happen? An error will occur because you're trying to access a non-static variable using a static block, which is not allowed. Why? Because you only think where is the non-static variables? It is not yet created. It is not there in the memory only. What is the point? How can you access it? If I execute, notice in the same program, okay, if I try to access or try to write the same thing over here in the static block, see, it will start showing me error. I will ignore the error and I'll start executing it. See, what is unresolved compilation problem? Line number 24 and 48 it is showing. Okay, so understand, these 3 lines are showing me error. If I go here, see, cannot make a static reference to a non-static field X. Okay, Y cannot make a static reference to the non-static field Y, and same thing is written for the Z also. It is trying to tell you that a static reference means a static element such as static block cannot point or cannot initialize or cannot call a non-static field. That means a non-static variable Z. The solution it is trying to give you is change Z to static, make it a static variable, then I can access it. But we don't want that. So remember, this is not allowed. Okay, this will cause you error. Now, second thing, let's assume I remove this. Okay, I try to comment it off from my code. Now what happens? Now let's say I move ahead. Okay, I try to move ahead and I'll try to execute what? The main method. Okay, so if I try to execute the main method, obviously the main method will be given memory in JVM and all that. But as soon as I do that, the very first line is telling demo.display1. So it's calling a static method. So the control from here will enter display1. It'll start executing A, B, C. Okay, value 10, 20, 30 will get. But as soon as it's trying to execute X, Y, Z, whenever you're executing X, it will show error. You're trying to print the value of X. Where is the X? Did you ever create X? No, because till now we have not created an object. Until we create an object, non-static variables will not get a memory. So again, we're gonna get error in X. I'll show you here. If I try to print X, Y, Z inside a static method, see, showing error. Again, cannot make a static reference to a non-static field X. Same thing for all the 3 lines. It is showing error. You can see here. All the 3 lines, same error. Because I'm trying to access a non-static variable from a static method. So remember, this thing I have already taught you in the very first slide. We have learned that only, that static variable, a static block and a static method cannot access a non-static variable. So I have also proved it here that it is showing the same error via this program. Okay, please quickly take a screenshot of this one as well. If you have any doubt, you can ask me.
Yes, sir.
Great. Now, the next thing, okay. So what we understood by the last few programs, the very first thing we understood is a class loader is a software whose duty is to scan the code segment and identify static elements. And then it would load those static elements onto the static segment. Second thing, execution of a Java program begins by allocating memory for the static variables. Third, after which, if there is any static block, the static blocks will get executed. We already saw that. After this, the main method would get executed. We also know that. Static methods can be called using the class name without creating the object. We also saw that demo.display1, we wrote it, correct? Non-static method must be called by creating an object and using the object reference, or we call it as a handle. We saw demo type d equals to new demo, then I told d.display2. Non-static block gets executed soon after object creation, and all the non-static blocks will get executed each time an object is created. As I told you, a non-static block, when did it get executed? When you start to create an object. And once you create an object, a constructor is always called, and always a super method will be executed. Whenever a super method is executed, as you saw, just after the super method, the non-static block got executed. Okay, so that is there. And each time you create an object, obviously the non-static block will get executed. Okay, these are the few thoughts. Again, just to prove you, that yes, sometimes my students, they tends to, they don't believe. Okay, this part, once again I'll show you this part. They tell, no sir, once the complete constructor is executed, after that only the non-static block will get executed. No, remember, just after the super method is executed, the non-static block will execute, and then only the complete constructor is executed, and then only the control flows back. To prove it, what I can do is, I will come back here. I'll write a small program to showcase it to you. Maybe I'll create a program here. Oh, 1 second. Static, yep. So let's say I have a class demo. In this class demo, I have a constructor. In the constructor, obviously the super method will be there. I write it or don't write it, same thing. After super, I've written, let's say, inside constructor. Okay. And at the same time, I'll say here there's a non-static block. I'll say inside non-static block. Okay. Now, as soon as I create an object, okay. Okay, demo is already there. Maybe I'll say dog. Okay, now if I execute this program, okay, let's see what happens. Now, will you agree if, as per me, what I'm telling, from here, okay, from the constructor call, the control will come here. After there, the very first line is super. From super, the control will go to the object class constructor. It will come back here. After coming back, it will not execute this line. Rather, it will come to the non-static block, execute this block, and then go back to the same line first. And after this, it will execute this line here. So as per me, this should come first, and then this should come, if I'm not wrong. Okay, so let's see if all this is happening or not. Now, if I execute this, see, first the non-static block and then the constructor. That is what is happening. So basically, always remember, it's the first super method. Whenever a super method call is made, Once the control comes back to this line, obviously first it will search for a non-static block. It will execute the non-static block, and then only it will execute anything inside the constructor. So you can either use a non-static block to initialize the non-static variables, or you can use a constructor to initialize the non-static variables. The job, the requirement is yours. Okay. If you want, you can take a screenshot of this. If you don't want, you need not take it. The choice is yours.
Sir.
Yeah.
Sir, why does it work like that? I didn't understand.
You understood the way it will work?
Yes, sir, but I understood the way it worked, but why I didn't understand.
That I also don't know, Ashish. The thing is, that is how James Gosling created the flow. We can't do anything about it. Yeah, there is no practical answer for that, Ashish. Actually, that's the sequence, right? So first static variable, then a static block, static method, non-static variables, non-static block, and like that. Even you see, whenever you create an object, new will give you a memory. Dog will do what? Initialize all the instance variable inside that, or create all those instance variables inside that memory. See, first the non-static variables gets executed, then you give a constructor call, super method executes, then a non-static method, non-static block gets executed. So it's as per the sequence. But why after super, I have no idea. That's how they have created it. Anyways, I hope you have taken a screenshot if you wanted to. Now, let us move ahead. I didn't let you take a screenshot of this one. So please quickly take a screenshot of this one as well.
Done, sir.
Okay. Now, the next thing I wanted to explain you is a program I have here. I'll first explain you through this place. Now, what is this program all about? Let me explain you. Now, understand that, okay, don't see the program. Listen to me first, okay? Let's assume there's a bank, okay? And the bank came to you because you're a developer and asked you to create a software, okay? Now you will ask the bank, hey, what kind of software do you want? They'll say, see, I want a software which calculates a simple interest, okay? It should take the necessary data from the user and should calculate a simple interest. Now, if you know Karnataka government, okay, what they will do, they will give loan to the farmers, okay, so that they can take that money, grow crop, sell, and then they can repay the amount that they have taken, and rest amount which is extra they can keep it from themselves, correct? So whenever a farmer takes a loan, he takes a principal amount for a particular time period, and the rate of interest is set, and once it's all done, he gets the simple interest. What the bank gets is a simple interest, correct? So understand, very simple idea. A farmer, once he applies for a particular principal amount, he wants to know what is the simple interest that he has to pay to the bank, and the bank wants you to create application for that. Now, keeping that requirements in mind, that I have to create an application for a farmer who, if he enters the principal amount, should be able to know what's the simple interest that he has to pay. Simple idea, simple logic, okay? So what I have done here is, understand, I have created a farmer class altogether, okay? Inside the farmer class, I have created 4 variables. All are for float type because you're dealing with money and simple interest. That is all in, that could all be in a point value or decimal value, correct? So I'm taking float. If you want, you can take it double. The choice is yours. But I am gonna make it private because I want to provide encapsulation. Always use the best approaches. Could have written, no, I could have not written private here, but I did write private here. Why? Because it is the best practice. I told you data encapsulation is very, very important. If I left it like this, anyone could have accessed the data and could have messed it with it. But I didn't let it. I wrote it private here. You have to write private. Okay. Now, once the variables I have declared, I have declared SI for simple interest, P for principal, T for time, R for rate of interest. Now I create a method accept input. The job of this method is to create a scanner object to take input. What input? Enter the principal amount. Now, because I'm creating this software in behalf of the bank, okay, so my customer will become what? The farmers. The farmers are going to be the one who is using my software. So the farmer is going to tell me, right, how much amount he wants to borrow. When you take a loan, you only tell, right, I want this much amount as a loan. So I'm going to ask the farmer, enter the principal amount. I'm going to store it in P. Then he should tell me for how many years he wants this loan, correct? Because understand, let's say you understand EMI option, right? Whenever you take a mobile phone, a laptop, or a car, you tends to go for EMI option. Now in EMI option, what happens? The amount is already set. In other words, you only told the principal amount by telling what you want to buy, and then you only select, right, I can pay it in 3 months, 4 months, 5 months. You tell the time period, correct? So here even the farmer will tell how much time he requires to pay the amount back. So I will store it in T. Now again, why float, you might ask? It can be 1.5 years, 2.5 years, 2.2 years. Okay, hence. But the rate of interest, I should not ask the farmer. Definitely the rate of interest will be decided by the bank. And because I am working for the bank, I should know the rate of interest. They'll tell me, okay, for every farmer, put the rate of interest at 2.5. So I've put the rate of interest directly. We cannot ask farmer the rate of interest. He might tell 0.0, or even worse, he will tell minus 2.5. The bank should pay a loan. The bank only should repay it back to the farmer. So rate of interest logically should be given by the programmer or the bank people. So this is the input method. Now I've written a compute method which is actually calculating the simple interest. I hope all of us in this session knows the formula for simple interest. That is in class 5, 6, I don't know when we have studied it. So principal into rate of interest into time completely multiplied by and divided by 100 is the simple interest. That's what I'm computing here. Finally, I'm displaying the simple interest. That is what I have written the farmer class. Now in the main method, I've written a farmer. I've created a farmer object telling F1, and I'm calling the accept input, compute, and display. So for the first farmer, I've accepted the input from him, I've computed the value, and I've displayed him the simple interest. Let's understand there is one more farmer. The second farmer comes in, accepts the input. I will accept the input from him, compute the value, and show him the SI. For the third farmer, I'll do the same. Okay, this is a very simple program. Let me execute this program and show you the output. It is asking me principal amount. Okay, if I enter the principal amount for the first farmer as 1000 for 1 year, I want to take it. See, the simple interest is 25 rupees. Now if I, for the second farmer, let's assume 2000 is the amount, 2 years he wants to take, 100 is the simple interest. Similarly, for 3000 amount for 3 years, the SI is 2 to 5. This is how my application which I created for the bank is working. Any doubts how about the program? I hope there is no doubt. Simple program. Okay, 3 farmers I've created. Each farmer, for each farmer, 3 methods are executing: accept input, compute, display. Can I get a yes or no that you have understood or not, so that I can move ahead?
Yes, sir.
Understood, sir. Yes,
Okay.
sir.
Okay. Now let us see how it will execute here. Okay. Assume there's a code segment. In the code segment, the complete program came and sat. Now what will happen? There is a stack and a heap segment as we know it. JVM will get loaded as we all know. OS will give the control to JVM. JVM will give it to class loader. Class loader will scan every static element and load it on the static segment. That's his job. Once done, it will give the control back to JVM. But as you can see, there's only one static element in the complete program. That is nothing but the static method. That is nothing but the main method. That only got loaded here. Now what? Now JVM will execute the main method. So as soon as it goes to execute the main method, again the control will enter the main method. So the stack of main method is created. The very first line is object creation, new. Again, a block of memory will be given. Let us assume the address is 3000. Farmer, it will go to the farmer class and create all the all the non-static variables. That is nothing but your instance variables. So SI, T, P, and R, all of them will get a memory in the object and they will initialize to the default value. For float, the default value is 0.0f. So in other words, 0.0. Correct? Finally, we're calling a constructor, but as you can see, I have not written a single constructor in the farmer class. I hope you remember. I really hope you remember that if we do not write a constructor inside a class, automatically the Java compiler would have added a constructor. I'm not showing it here. I'm just telling you. I hope you remember. And it will add a default constructor. Okay, a zero parameterized constructor. And once inside that, the very first line and the only line will be super method call. That will call the parent class construct, that is object. For farmer, there is no parent I have written, so automatically object class is the parent class. So parent class, that is object class construct, will execute and the control will come back to super, and from there it will come back here. Because I'm not initializing anything, nothing will happen. After that, LHS will execute, that is F1. Okay, so F1 will be created and will start pointing towards this object. Now what? Now I told F1.accept input. I'm calling another method. So again, the control from main will enter accept input method and the stack will be created here. Now because accept input as the top of the stack, will start executing accept input. See, in accept input, what is there? Scanner object got created. Enter the principal amount. P equals to scan.next float. So I entered the value here. So as you know, P value will be entered, T value will be entered, and R value you have already given, so it will be overridden in this object. Okay. Once done, nothing is left. So this will be deleted. I'm not deleting it. I hope you understood that it will be deleted. Next, we call the compute method. So compute method activation record will come here. And remember, it is not there. This particular accept input is removed. So main, above main, directly compute is there. Compute method is calculating the value. You can see P into R into T by 100. So we have T, we have R, we have P value. So this will be multiplied, divided by 100, and it will be stored in SI. So what will happen next is the value of SI will be changing to 25. After that, this will also get deleted. The next line in main method is display. So display method activation record will be created, and display method SI is showing what? SI equals 25. See, that is what we have got here as the output, if you notice. Okay, that's where the execution of the first farmer finishes. Similarly, for the second and the third farmer, again the same thing will happen. So I hope you've understood it. So I'm going to fast forward it like this. Okay, for the second and the third farmer, same thing will happen, and we'll get the solution, this SI 100 and SI 25. Okay, so this is how this program actually executes at the background. Any doubt in this program as of now?
No, sir.
Yes, sir.
Okay, but understand. Okay, tell me, is this program is running fine, right? We are getting the output. The bank requirement is completely fulfilled. They told me to find the SI for a particular farmer. by when they enter the principal and the time. I did that. Rate of interest I knew. I calculated it. I showed him the value. Is the program working fine? Is the requirement of the bank fulfilled? Yes. But if I code this and give it to the bank people, will they accept it? Or will my company allow me to sell it? No. 100% your program, this program which you have written, will be rejected. Now you might think, why, sir? Why my program will be rejected? Because it doesn't meet company standards. You have not used the best practice available. Yes, you are getting the solution. See, understand, all these days when you sit for your computer lab, you gave the exam, you coded the programs, no problem. All those time, actually getting output was very important for you. But to get a job, getting the output is not enough. Let me be very frank with all of you. Maybe it's cruel, maybe it's straightforward, but it is very straight. If you think, okay, I wrote the answer, I gave the solution, the answer is correct, I'll get a job. No, that's a straightforward no. You will not get the job. You will be rejected. Even though your answer is completely correct, you will be rejected because your answer doesn't meet the expectations that are required or that are set. Now, why am I telling all this? The reason. Watch and notice carefully. Tell me, in the heap, you created how many objects? 3 objects. Now, in every object, you created 4 variables. Okay. Tell me, do you think see something in all this object which is common? Anyone? It's a question for all of you.
Variables.
Okay. Yes, the variables are common. Any data of any variable which is common or constant throughout all the objects?
Rate, sir.
Yes, the rate of interest. If you notice, the rate of interest is common for all the objects. It is same. So don't you think, rather than creating multiple copies of rate of interest, we should have created only one rate of interest, and that one single copy should be shared among all the objects, rather than creating a individual copy for every object. I could have created a single copy and I could have asked all my objects to use the same copy because the value remains same and we're not changing it ever. It is fixed. So in a case where you could have created a single variable and asked all the objects to share it, what you did, you created the same variable multiple times for each object individually, whereas the value remains the same. This is not a good approach. Now you might say, sir, what's the problem? One single variable, sir, no problem. Yes, in this program, no problem. But think about it. R is of what type? What is the data type of R? Can anyone of you tell me? What's the variable data type of R variable?
Float.
Float. How many bytes it consume if you were present in the data type class?
4 bytes.
Exactly. Tell me, 4 bytes R is consuming. Here, how many bytes have it consumed in a complete memory? 12 bytes. Will you agree? But if you would have created one single R variable and it would have been shared with multiple farmers, only 4 bytes of memory would have been utilized and everyone would have used the same thing. But because you didn't take that approach, you took this approach. What is happening for each farmer? 4 bytes of memory is getting wasted. And no problem. Yeah, we have GBs of memory. You can argue with me with the question, sir, what are you telling? 4 bytes, simply I'll give away. No problem for me. I have GBs of memory. Yes, I agree. But here we're talking about 3 farmers. Understand, there are not 3 farmers in Karnataka. There are more than lakhs and lakhs of farmers. If there is 1 lakh farmer, you're wasting 4 lakh bytes. That's a huge amount of memory. Okay, so your code will not be judged for a small byte because you have huge amount of memory space. No, each memory space you waste will be counted. Okay, so understand, in a competitive exam, if you write this program and another person has written a program where same programs, everything same, but he has created R as a common copy, his memory consumption will be less, his program execution will be little faster, and even though both of you have got the output, he will be selected and you will be rejected. And that is the hard fact reality. That is what happens. Okay, now let me show you how you should have written the solution. But before that, quickly take a screenshot of this one, and if you have any doubt, you can ask me.
Yes, sir.
Okay, so with that, I don't think so. The if you want to take the output also, you can take the output screenshot. The choice is yours.
Yes, sir. Take it.
Okay, now same program I would have written in this manner. I'll show you. Okay, this is how I would have written it. What changes did I make? Okay, I've written farmer one because already farmer I have in my other program, so I cannot create two classes with the same name. Okay, so don't go with the name, just see what I have written. Same thing, I've created three variables, si, p and t, which is private, which is float type. I've also created r, which is float and private, but I've created r as a static variable. Okay, what is the difference? I'll tell you later, but I've created as a static variable. To initialize it, I've used the static block. I told you static blocks can be used for initializing static variables, and that's what I have used it for. Then rest everything remains same. I have told accept input. I am accepting p and t because r already is taken care of. I'm not including r here anymore. I have compute, I have display, everything remains same. Only thing I did is I told my program to create r as static variable, and to initialize it, I've used a static block. Even let me execute the program and show you. Okay, if I execute the program, I'll give the same input: 1000, 1 year, 2000, 2 year, 3000, 3 year. Any difference in the output? Not even a drop, not even a full stop of difference is there in the output. 25.0, 100.0, 225.0. Output remains the same. What changed? Memory changed here. Let me show you. Okay. Now again, code segment, new code is there. If you notice, I have included static variable r and static block. We have stack and heap. JVM got loaded as we all know it. OS will give the control, and JVM will pass it to the class loader. Class loader job is to scan the complete stack code segment and load the static elements. Previously, we only had main method, but this time we have static variable, static block, and static method. That is nothing but the main method. So class loader will give back control to JVM. JVM will start to execute the static block. Static segment. Now notice, the very first variable is r, so it will give the memory for r, and the initial value is 0.0 because it's a float type. Second, it will execute a static block, which is initializing the value to r, so it will become 2.5. Now next is the main method. So once it executes the main method, it will again create a main method stack. Again, the very first line happens to be object creation, so new, a block of memory will be given with our address. Let us assume 3000. Farmer, all the instance variables or non-static variables will be created inside that. So it is si, t, and p. No r, because understand, r is no more a instance variable or non-static variable. It's a static variable, so it got occupied in the static segment. So here no more space is occupied. Okay. Now Once they are done, constructor call is there. I have not written any constructor, so default constructor will be added, super method will be called, all those things will happen. Okay, once the control comes back, f1 will be created here and it will start pointing towards this one. Then I'm telling f1 dot accept input, stack will be created. Now object will be created, inputs will be taken and the value will be updated like this, p and t will be updated. Now again, after that, f1 dot compute, so compute method will do what? It will calculate si. So see, its si is calculated. After that, we have to call display method, and display method will do what? Display the value of si, that is 25. Now same thing which I am telling is going to happen for rest of them. But understand what changed. What changed is, because you created r as a static variable, it allocated the memory in the static segment. Okay, because it allocated memory in the static segment and you initialize it with the stack, now it will not occupy memory in each object. Okay, now there is no individual copy for all the objects. So if they're trying to use the value of r, see, they're using the value of r in this compute function while calculating the si. Do they have r value in their object? If let's say farmer 1 is, for farmer 1 we are calculating the si, does it have r as a variable? No. Where is it present? In the static segment. So it's going to take the value from here and calculate the si. Again, for farmer 2, when we are calculating the si, he doesn't have a r value. Rate of interest, he doesn't have it. So where he is going to borrow it from? Static. Again, third farmer is also going to borrow it from static. So all the objects are sharing a single copy. Okay, a single copy of rate of interest is being shared with all of them. Now you think, if there are 4 farmers, how much memory are we occupying? 4 bytes. If there are 1000 farmers, how much memory are we occupying? Still 4 bytes. If there are 10 lakh farmers, still we are occupying 4 bytes. I hope you can see the difference between the program. Now you only think, if I as a programmer would have written this program, would you have selected me, or you would have selected yourself who have written the program where every object has r value? You yourself judge whom you would have selected in the interview. Definitely a person who has written r in this manner, correct? Because it is saving me a lot of memory. So this is how your thought process should start working. You have to think before you take a step. You have to think, okay, will this variable be shared among all of them? Is the value same? Is it constant value which I'm not going to change? Is it? Then I'm going to take it. Okay, I cannot take, remember, I cannot take p here, because p is a principal amount. It can change with every now and then. Again, I cannot take t, because it will keep on changing with every farmer. It will keep on changing. So I hope you're getting the idea here now. Okay, is this clear to everyone? Can you give me a yes by unmuting?
Sir,
Or
I have a doubt, sir.
yeah, ask me.
Sir, as you said, there are lakhs of farmers in our state. So, sir, it would also be possible that the time would also be same, no, sir? Time duration of many farmers.
Yeah, but
So,
many farmers, not all farmers, right, Ashish?
yes. But even we can save a lot of storage if we create only like
Yeah,
how we did
definitely.
for the.
Rate of interest, you want to do the same thing for time, right?
Yes, sir.
But understand that will not be logical. Every farmer, see, let's say you and me, we both are farmers. Okay, so you are sure that yes, this is a season where I can grow my crops, so I can repay the amount very fast. I can repay the amount in 1 year only. But let's say I'm growing such crops that I know that this year, this time is not the season. My season will come next year again. So I will at least need 2 years to repay the money. Then again, you can repay the money in 1 year, I can repay the money in 2 years. So there's always a difference. If 99 farmer 100 farmers are there, 99 can be same, but at least one will be different. So there is a chance that there is a difference between them. So if there is, so don't create it. Then your uh, software will have kind of a bug that everyone has to pay the amount in the same date, which is not a suitable way. I hope you're getting the idea.
Yes, sir.
Okay. Any other doubts? Have you all understood why I'm using it? Basically, I'm trying to tell you how to use and what is the use of static variables. By this program, you have understood the use of static variables. Did you understood it?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Please take a quick screenshot of this one. I hope I did not show you the output because the output is completely same as the previous one. Again, I'm just repeating it for your thought process. Remember, whenever you want to have a single copy which has to be shared by multiple objects, make it as static. If you want every object to have its own individual copy, then make it as non-static.
Yes, sir.
Okay. I hope you have taken the screenshot. I know I'm moving continuously. I'm not giving a break. Don't worry. I'm going to leave you early though. Okay. I'm almost done. Just a quick revision for everything. Static variables must be used whenever a common copy of variable must be shared by all the objects of a class. I hope you have understood this one. Second, static variables are not allocated memory within the object. Instead, they are allocated memory in the static segment. We saw that. Static variables are also known as class variables because a single copy of the variable is maintained for all objects of the class. As we saw, R was there for all the objects of the class farmer. What is the advantage? Efficient memory utilization. Second, easy maintainability. Tomorrow, understand, if I have to change the rate of interest, I have to increase the rate of interest to 3.0. I need not go to every farmer object and change it. I can only change it in the static. It will be changed for all the farmers. Easy maintainability. Okay. Now, next thing is static block. Then now I'm going to explain you what is the use of static block. Very simple it is. Okay. No need to think also. Tell me when static block gets executed. What is the step? First step, second step, third step. At what time the static blocks get executed? Question for everyone.
After static variables, sir.
Yep. In the second position after static variables. Also before the main method, because after static block, the next is method. So main method. Correct. So we can say either after static variables or before main method. So also, don't you think it's useful for you? Today, if I want to execute something before the execution of main method, I can write those things inside the static block. Notice, static blocks are used to initialize static variables, to execute a set of statements even before the main method executes. Because the static block executes after static variables, you can initialize static variables using static block. And because static block executes before main method, we can use it to execute a set of statements before the main method. Just to showcase it to you, let's assume this is a program where I have written a static block. I have written the main method. You will notice the output is inside static block first and then inside main method. See, the output is inside the static block and then inside main method. Okay, I'll show you the program also. I will say, sir, that output you only have written. How can I, trust it? Yeah. Tell me.
We'll take that screenshot.
Yeah, I'll give you the screenshot. I'm just showing you the output. See, inside static block and then inside main method. Okay, showing you so that you later don't tell sir this sir you only have written, how can I trust it? I showed you by Java compiler execution that anything you want to execute before the main method, you can write in the static block. Okay, I hope you have understood the use of static block as well as static variables. Please quickly take a screenshot. Any doubt, please do ask me.
No doubts.
Great. Taken the screenshot?
Yes, sir.
Yes.
Yes, sir.
Okay. Now the last thing that is left is static methods. Okay. Now understand, forget static methods for a second. There are two types of methods in general. In general, if you see, there are two types of methods. Okay. First, they're called as specific methods, and this question might pop up in interview. What they tend to do is they don't tell it as non-static method. They call it as specific methods. Okay, understand this very clearly. They are such methods whose behavior is different for different objects of the class. And I mean, what do you mean by that? If the method is same, okay, but when you execute it for a particular object, it might be different. For a different object, it might be different. So depending upon each object, okay, the behavior of the method changes. Okay, those methods are called as specific methods because they're specific to each object. Such method must be declared as a non-static method and can only be called by creating an object of the class. So these are nothing but the non-static methods. They are also called as specific methods. So remember this. It's a way to trick you. So don't tell, oh, what is specific method? I don't know. Nothing but non-static methods. Okay. Second, they are called as generic methods. They are nothing but your static methods. They are such methods whose behavior is same for all the objects of the class. You create 100 objects. For all the objects, the method will execute in the same manner. Such method must be declared as static and can be called without creating the object, rather just by saying the class name, which you just saw, display1. We can call it directly through a class name. So static methods are also called as generic method. Non-static methods are also called as specific methods. I hope this is clear for all of us. Now, just to show an example about specific method. Now think about it, okay? Simple example. IPL is going on. So IPL example for boys and girls who watch cricket. Very simple example. Let's say today I ask you, what is the heartbeat of Virat Kohli? Don't you think I'm being very specific here? I'm telling, tell me the heartbeat of Virat Kohli. Now you don't know. You know that you might know the average heartbeat of a human being, but you don't know at this particular moment what is the heartbeat of Virat Kohli. It might be a little bit high because he's playing. Maybe it will be a little bit relaxed. Anything can happen, correct? So understand, when I'm asking you for the heartbeat of Virat Kohli, I'm being specific. That's a non-static method. If you write a method to calculate the heartbeat of Virat Kohli by taking an input from Virat Kohli, it is becoming specific. Okay, watch this example. I've written a class human in which I've written void heartbeat. So this heartbeat is such a method which is specific to each object. Now, if I create a human object with the name Virat, so I'm telling that I'm creating an object for Virat. So I'm being specific here that this method I'm calling for Virat. So I want to store the heartbeat of Virat here. Similarly, if I create one more object, human Sachin equals to new human. So I'm asking to store the heartbeat of Sachin Tendulkar. So that is again specific. Don't you think every method value will be a little different? Every method, I mean, the same method's behavior will be different for every object. That is nothing but specific method. Same method behavior will be different for different objects of the class. These are called as non-static methods, or we can also call as specific methods. Similarly, let's take a generic method. Let's say I tell you today, can you tell me what is the average heartbeat of a human being? You'll instantly tell by Googling, sir, this is the average heartbeat of a human being. Simple. For that, if I write this program, don't you think it's very much obvious? I wrote a class human. In the same class human, I wrote static void average heartbeat. Now tell me, for average heartbeat, I need not be specific, right? Whose heartbeat it is? Average. In average, almost all the people have similar heartbeats. I'm guessing that. So this is common for everyone. In other words, this method's behavior will be same for all the objects of the class. And hence I've created it as static. And hence I can call it directly through the class name. I did not create an object for it. So this is our generic methods. Any doubts in this specific method and generic methods?
No, sir.
Okay, great.
Yes, sir.
Please quickly take a screenshot of this one.
Yes, sir.
Okay, with that, today's session ends. Okay, you have completely understood about static everything. Okay, I have ended the session at least 20 minutes before, if not 21 minutes before. Okay, so with that, today's session ends. Okay, we have also finished with static. Can we initialize the value of R in the main function, sir? Okay, let me ask you this, Trisha, sorry. You're talking about R variable, correct? Trisha?
Yes,
We need
sir.
to, yeah. So R is static variable. R is static variable, correct? Tell me, if you remember the PPT very first diagram, okay, where I was talking about accessibility. Tell me, can a static method access a non-static variable? Shisha?
Yes, sir.
Hey, know how it can access. I'll show you. It's okay. You just saw the thing. No, maybe you forgot. I'll show you 1 second. Afterwards, we can get extremely slow. Just give me 1 second, people. Okay. I hope it should open faster now. Yep. See, you're asking me, R is a static variable, sir. Can I initialize R using a main method? Correct? Now understand, main function is what? Static method at the end of the day. Correct? And R is a static variable. Can a static method access a static variable?
Yes, sir.
So can we initialize it?
Yes, sir. But, sir, I didn't mean that it is a static variable. Even if it is a public variable, can we initialize in main method?
Depends, Sresha, how you write the program. The completely depend upon the program. See, from the main method, you can access static variables, but you can also access non-static variables. Okay, using main method, you can access non-static variables, but only after a non-static method is executed. Okay, so once you have created the object in the main, inside the main method, once you create an object, after that, if you are trying, you will be able to access, because till that time, it would have already created the non-static variables. But at an early stage, even before creating an object, if you try to access using the main method, it will not be able to access it. That's why I've created a red here. But yes, at any point of time, a static variable can be accessed using a static method. So that means main method. Okay.
Okay, sir.
Okay. So with this, we end. Okay, one more thing I just wanted to showcase to you. What is the next topic that you're gonna learn on Monday?
Excuse me, sir.
Yeah, tell me.
Sir, I just missed to take screenshot of the methods, static methods, types of methods.
1 second. I don't know.
I got disconnected, so that's why.
Oh, it's no problem, Ashish. I'll show you. I don't know. Today my laptop is working really, really slow. Okay. Just a second. Let me show you the method. Yeah, this one, right? Ashish.
Yes, sir, yes.
Yeah. Take a screenshot.
Done, sir.
Okay. Okay. So we finished static today as well. Okay. So next is inheritance. Very important, people. In any interview, one question from inheritance will definitely be there. Okay, inheritance is nothing but the you saw me writing right, dog one extends the object. That is nothing but inheritance, creating a child and a parent relationship. Okay, and how it all works at the background, very important. It might take me few days to finish it, at least 1 or 2 days. In one day I cannot finish it. It takes at least normally 3, 4, 5 days to finish it completely, but I'm going to cut short few things which are not that important, and I'm going to teach you what is very, very important and will come to the interview. Okay, so don't miss it. Don't miss it at all. Monday, don't be late to the class also. Okay, very important. This topic is this is one of the pillars. We call it as, see, there are 4 pillars of Java. Okay, one is encapsulation, which you already know. Second is inheritance. Third is polymorphism, and fourth one, I'll let you discover it yourself moving ahead. Okay, that's okay. I'll tell it only. That is nothing but polymorphism. Okay, you have already seen virtual polymorphism when I was talking about method overloading. Okay, but now you will actually see how polymorphism can be achieved in Java. Means you write one single line, you can execute it for different behavior. Okay, I mean, same line executing will give you another output, same line executing again will give you another output. Polymorphism, one, it's too many relationship, one method will do multiple jobs. Okay, how can we achieve it? We'll see. Anyways, today, that's all for today. I hope you use the rest of the day for doing something productive. But anyways, don't forget to take a rest. Don't burn yourself out completely by studying. Okay, take some rest on Sunday. I'll go out. No, don't go out. I mean, be safe. But yeah, do revise, guys.